Now today we are going to go over singly linked list, but before that, what exactly are linked lists? Now linked lists are like arrays, so they're pretty similar, except that linked lists create a chain of connected objects using classes, and this object is actually called a node. So it creates a chain of nodes. So we're going to have multiple nodes. Each of the objects are a node. We talked about that. That has two properties. First one is a value and second one is a pointer. Now, before we illustrate what a linked list is, let's go over what an array is. So array looks something like this, and let's say that we have 5 elements, and arrays are indexed, right? So the first one has an index of 0, 1, 2, 3, 4. And these elements are our values, so 1, 2, 3, 4, and 5, and they're indexed 0 through 4. For linked lists, we are going to again have nodes. So let's say that this is our node, and right now we have total of 5 nodes. And these nodes are going to have again two properties. First one being value, and second one being a pointer. So we know what a value is. Our values are 1, 2, 3, 4, and 5, and so on and so forth. But what are our pointers? Well, our pointers are just literally a pointer that points to a node. So let's go back to our linked list. So this is an array. This is a linked list. Our node 1 is going to have a value of 1 and a pointer of node 2, which is this node. And we're gonna just arbitrarily make a pointer that points to node 2, and this node 2 is going to have a value of 2. This is going to have a pointer of node 3, and it goes on and on and on. So each node has a value and a pointer, and pointer just simply again points to a different node, just like how we have over here. And this pointer, we are going to call it next, and this makes a little bit more sense, right? Well, it points to the next node in line, whatever that is. So unlike arrays, our linked lists aren't indexed. It doesn't have any index. It just points to another node. Again, node is an object that holds data, which is our value, and reference to the next node in the list, which is our pointer. And linked lists can have two ends. But first, we are going to implement our solution just working with head. And next, we will implement a solution where we have both head and a tail. And what do they represent? Well, it simply represents the element at the beginning of linked list for our head, and tail just simply refers to the end of our linked list. So for our linked list that we have over here, this would be our head and this would be our tail. And you can actually implement a linked list without a tail, so without this, but you have to have a head. Or you can have head and a tail. That's totally up to you. But for our purpose, we will start with head, and you can try implementing it with tail on your own, but I think we'll probably implement this too later after we're done with just implementing the first one. And singly linked list has one connection to another node, hence the word singly. And what was that connection? Well, that connection was our pointer, our next pointer. Later, we're going to implement doubly linked list, where we're going to have nodes just like before, but this is going to have two pointers. One is next and another one is previous. So it looks something like this. But let's save that for later. Now, what are the advantages of using linked list versus an array? Well, first of all, we don't really need to reindex our elements when adding or removing elements in the list, meaning array to be exact. We just need to change the reference points being our pointers. Next, elements can be stored anywhere. No need for contiguous memory location. Now, if you don't know how memory works, let's say that this is our memory. Now, if you need to store our arrays, we need a contiguous memory, meaning we need to occupy space like this. So it has to be connected. Whereas for linked list, if this was our memory, so let's say that each space occupies one element. So we have 1, 2, 3, and 4. We have 4 elements, right? We can have one here, we can have one here, we can have one here, and we can have one here. So it's more efficient in terms of memory usage because we don't need a block of space in our memory. And if you have other stuff going on your memory, it's obviously hard to keep a contiguous memory, right? Whereas for linked list, you can just put it anywhere in the memory that has a spot. Now, what are some disadvantages? Well, there is no direct access. And if you remember from our array implementations, what was the time complexity for access? Well, access is cheap, so it was O of 1, because as long as we know the index, we can get the element right away. So for linked list, if we want to search for a value or a data, we have to traverse through the whole list until we find the element that we want. And that's going to be expensive, right? So that's O of n operation. Also, we have to keep track of the next element, meaning the next node. So we need a extra space, which is going to be this pointer for us in our memory to keep track of the order of our nodes. So that's another disadvantage. Now, let's briefly go over our time complexity and space complexity. Well, space complexity is going to be simple because it's going to be O of n. It's going to depend on the number of inputs. Next axis is O of n, and we talked about it over here, and that's because we would have to traverse through the whole list if we were to look for an element. But it's going to be O1 for head because, again, head is also a pointer that just simply points to the first element. And if you were to look for the first element, since we have a pointer that points to the first element, and that's called a head, right? So we can access that O of 1, but otherwise it's going to be O of n, and search is also going to be O of n, because again, we have to traverse through the whole list. Now, for the next two operations, which is going to be insert and deletion, there might be some confusions when you look up online. Now, when we talk about insertion and deletion, we talk about two different operations. Now, if you were to insert a element at the middle of our linked list, you probably have to traverse through the list and then find whatever position you want to put it into and then push it in there, right? So that's a O of n operation in worst case. How is it that insert is O of 1? It's the same case for deletion too. Well, when we talk about insertion and deletion, we separate two operations. And first one is searching, and second one is inserting and deleting of elements itself. So this will probably make more sense afterwards, but let's just briefly talk about it. We'll go over this more in detail. Well, in order for us to insert a element in a linked list, we would have to traverse through the list until we find the previous node. And the reason is because remember that our node has a pointer, right? And if you were to add an element in the middle, you obviously have to set the previous node's pointer to the new element, and the new element would have to point to the whatever was next to the previous node. So searching for the previous node is an O of n operation, but adding or deleting the element itself is a O of 1 operation. And the reason is because we simply just have to change the pointer for our new node. So that's why it's going to be O of n for search and O of 1 for actually inserting or deleting the element. If this sounds confusing, that's totally fine because we will go over this again later when we finish our singly linked list. But just do know that for inserting and deleting, we have actually two different operations where first one is searching and second one is actually the insertion and deletion itself. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's implement our node class, and remember our node will have two properties. First one is the value and next one is the next property, or this is the pointer property, which will be used to point to the next node in line, and this should be just 1D. So if this circle represented our node with a value of 1, so we will have a value of 1 and we will have a next property. Now let's say that we have another node which is going to be node 2, and it's going to have a value of 2, and it's also going to have a next property. Now this 1 is going to point to 2, so next property is going to point to node 2, and if you were to have one more element, 3 here, our value would be 3, and our next property, let's just leave it for now, this will be pointing to node 3, and let's say that this was the end. If this is the end, we're going to set it to null. So next will be null right now. So let's implement our node class. Now we need to bring in our constructor function. which is going to take in a value, and we need to set our properties now. So first one is going to be this dot value, and this is going to be the value that's going to be passed in. And next one is going to be called the next property, and we'll set this equal to null. And if you remember, if we don't have a next node in line, it's going to point to null. And this was the case when we had our node 3, which was the last node. Now let's implement our linked list. And for this one, we will do something different that we didn't do for our stacks and queues. This one will be able to take multiple arguments. And if it does have some arguments, when we instantiate a new instance of our linked list, it's going to add those values into our linked list. Whereas before, we would add one by one each time. When we pass in an argument for our linked list, it's going to add all those values. So it can be an array, number, or a string. So we will need a constructor function to be able to hand those arguments. Next, we need to have a head property, and this is going to be set to null. And remember that head just is another pointer that points to the first element in the linked list. Next, we want a length property to track the length of our linked list. And finally, you want to be able to handle those different arguments. Now, if it's an array, you want to be able to iterate through the array and push elements to it. Otherwise, you just add those elements to our linked list. Now, let's start implementing our linked list. First thing I want to be able to do is I need to handle multiple arguments. And next, I need to set my head property, which is going to be null. And when this is null, that means that our linked list will be empty. Next, I need my length property, and I'll set it to 0 because our linked list is empty for now. Next, I want to create a variable, and I'll call this args. And this is going to be all my arguments in an array. And later, I'm going to iterate through whatever is inside this array and handle adding them to my linked list. Now, let's try iterating through our elements. So let's use a for of loop. So for const arg of args, and this is actually wrong. This should be arg. So if my argument is an array, so if array.isArray, so if my current argument is an array, I want to iterate through my array and push in the elements, right? So I'm going to have another loop. Let's have a for of loop again. For const value of arg, we want to push it into our linked list. So we'll use this dot push and we'll pass in our value. Now we haven't implemented our push method yet, but we're going to do that later. So let's just leave it here for now. And then next, we have to handle the case when it's not a array. So else we just want to run this dot push, pass in our value. So we can't test this out, this function right now, but let's do that after we implement our push method. But let's first create a new instance of our linked list, see if that works. Now let's call our linked list just ll, new instance of our linked list, and let's just console log our linked list. So right now you can see that we have head and a length, right? But let's console log stuff so that we can see our methods inside. Now what we have to do is we have to console log object dot get on property names. And if you were to pass in linked list, you can see that we have three things. We have head, length, we have length, prototype, and name. So if you remember what prototype is, remember when we implemented our, I think it was queues and stacks, we were adding our methods to our prototype, right? And we were able to access those methods like it was a native method. So let's try printing our prototypes. So we'll do the same thing. You just do dot prototype. And here you can see that we have our methods that we are going to implement later for our linked list. So we have push, pop, unshift, all the way to values. We obviously haven't implemented them yet, but we'll do so later. Now let's implement our push method for our linked list where we insert an element at the end of linked list. Now first thing you want to do is you want to create a new instance of node and pass in the value given so that we can add this node to our linked list. Next, you want to create a variable to store current node for now and set it to head. Well, this variable is eventually going to point to the last element, which we'll call it tail for now. So this variable again is going to point to the last element in our linked list. Next, we need some checks. Well, if it's empty, that means that there aren't any nodes in our linked list, right? So what we're going to do is we are just going to simply set our head to the new node. Otherwise, if there are elements in our linked list, we want to traverse through our linked list until current node has a next property. Okay, so what does this mean? Well, let's first draw a linked list. So let's say we just have two elements and we have our 1 pointing to 1 and 2 pointing to null because this is our last one. This is technically our tail and this is our head. And if you remember, head is always going to be the first element and tail is always going to be the last element. And null is obviously not an element, right? It's just empty. Now, it's saying that we want to iterate or traverse through until linked list current node has a next property, right? So right now, the property of the second one is null and property of the first one is, let's just leave it as 2. So we want to traverse through the linked list until we find the last one, because last one is always going to have a next property of null. And when we find that, what we want to do is we want to set this new next property of tail to the new node. And let's say that the new node is 3, which is just hanging there because we just created it. So we're going to link our next property to 3. And now that means that we won't have this connection over here. This is gone now. And this 3 will point to null. So we now successfully added a node to our linked list. And obviously this won't be the tail anymore. Now this 3 will be the tail. But remember that right now we aren't going to have a tail property. We're just going to have head for now. After we're done, we want to increment our link by 1 because we have one more element, which is 3. Now let's start coding. So first thing I want to do is I want to create a new instance of my node. So let's do const node is going to be new node. Remember that we created a new node class. And let's pass in our value. Okay, that looks good. And we want to create another variable to store our current node, which eventually is going to be our last node. So let's just call it tail. And this is going to be first set to this dot head. Next, we need our if statement. Well, if it's empty, that means that we can just set our head to the new node, right? Or we can set our new node to the head. Well, how do we know if our linked list is empty? Well, it's going to be empty if it doesn't have a head. So if head is null, that means that our linked list is empty. Or you can just do length. It doesn't matter, but I just want to leave it as head. So if it doesn't have a head, that means my linked list is empty. So if it's empty, what I simply want to do is I want to set my head to the new node. So this dot head is equal to the new node. What if there are elements? Well, if there are elements, we have to traverse through our linked list. So while my tail.next has a next property, so as long as my current node that I'm iterating through has a next property, I want to keep iterating. And you can call, if this word confuses you, you can call it current. That's really up to you, but let's just leave it as tail because eventually this node is going to find the tail of our linked list. What I want to do is I want to set my tail to tail.next. So what am I doing here? Well, this is how I'm actually traversing through my linked list. Well, as long as my current node has a next property, I want to set my current node to my next node. So if you remember, we had node 1 and 2, right? So at first, my tail is going to be node 1. And my node 1 had a next property because it was pointing to node 2. Well, that means that this is going to evaluate to true. And my tail is going to be my tail.next, which is my node 2. So after one iteration, this becomes node 2. And we run this again. Well, does tail.next have a property? Well, if you remember, our node 2 was the last element. So we stop there and exit out of this loop. And what do we want to do after we exit out? We want to set the next property to the new node. So that's going to be tail.next is going to equal to the new node, which is represented by node. And finally, what do you have to do? We have to increment our length by 1. So that's going to be this dot length plus plus. So let's try if our code work. Let's do linked list dot push, and let's just push it 1, and let's console log our linked list over here. And you can see that we have a node of value of 1 and the next property of null, because right now we only have one element and it has a length of 1. So let's try adding more elements. And you can see that we have element or node 1. So head is pointing to node 1, and node 1 has a value of 1 and has a next property of another node, which has a value of 2, and it's pointing to null for now. Now, if you were to add one more element, you can see that we still have the same thing, but right now it's just an object. Well, if you remember, our node is an object, right? So it's currently not just displaying it, because right now we just have too many elements. So to see our elements, what we can do is, let's go all the way back up, and we're gonna require something. And what we'll do is we're gonna bring const util, and this is going to equal to require util. And what this does is it just returns a Spring representation of an object. Now let's go back down again. So right now our third element is just showing up as an object, and that's because it's just not printing everything, because it's just going to be too long. So what we have to do is we have to convert everything into a string so that it prints it properly. So to do that, we'll do console.log util.inspect, and we're going to pass in our linked list. Here you can see that our object just changed into a node, right? And to see our node, what we have to do is we have to actually pass in one more thing. We're going to pass in something called depth, and let's just say 5 for now. And now you can see all of our node printed correctly. So this is more readable too. So we have two properties in our linked list. First is head, second is length. You can see that our head is pointing to this node, which has a value of 1, and the next property, which is another node, which has a value of 2, which is a next property of node, which is a value of 3, and that's pointing to null. So this node with a value of 3 is the last node in our linked list. So do take a minute to just look through this. At first, I thought it was kind of confusing because there's just so many things. There's like so many next, there's so many nodes, there's so many values. If you take a look for a while, I think you'll understand how this whole thing works. So 1 points to 2, 2 points to 3, 3 points to null. So 3 is the tail. So that's it for our push method. But now, if you remember, when we created our linked list class, we made it so that it can take multiple arguments, right? So let's see if that worked. So I'm just going to uncomment this. I'm going to get rid of this because that just shows two little nodes. I'm going to create a variable here named initial, and this is just going to be my initial values. Let's set this equal to, actually let's not create another variable. Let's just comment this out and create a new instance of our class linked list. That's going to be new linked list, and let's just pass it here because I want to be able to pass in some values too. So let's pass in 1, 2, and let's pass in an array 3 and 4, and it says value is not defined. So we made a mistake actually. Okay, so this is our linked list class, and we actually made a mistake. We did this top push value. Well, it's not value, it's value for, if it's an array, it should be arg, right? I hope you caught that mistake. It should be arg. And let's go back down. It should work now. So you can see that it worked well. We have 1, 2, 3, and 4 with a length of 4. So we added 1, 2, just single elements, and 3 and 4 in an array. We have 4 elements. First one is number 1, which points to 2, which points to 3, and which points to 4. And finally is pointing to null because 4 is the last element to be added. So it added 1, 2, 3, and 4 in that order, which is what we exactly wanted. I'm just going to uncomment this because we know that our constructor function was coded correctly, and let's uncomment these for later. Now we have a property of depth for 5, right? And that means that we're going to be able to see only up to 5 nodes. And if you change this to another number, you'll see more. But for my example, I'm just going to work with a limited number of nodes because if you were to have too many, it would just be too long. Now I want to go over how push method works step by step. So I want to go over the code one by one, line by line. And when I first started learning data structure, starting from linked list, I was really lost because I have so many things called this dot head. We're going to see tail later. I see so many next properties and it really confused me. So I want to go over this line by line. Now, first thing we do is we create a new instance of our node. And that's, if you remember, that's our circle with a value and a next property. And next property is always set to null and our value is passed down from our value. So up here. So let's say we got 1 as our value for now. So we have the node of 1. And next we want to create a variable called tail and set this to head. So to the first element of linked list. And if you want, you can actually call this current or whatever you want. I'm simply going to name it tail because eventually this is going to be the tail node of our linked list. Now we have our two if statements. Well, if my linked list is empty, I want to set my head pointer to my current node. Okay, so let's go over how that works. Now let's say this is our linked list and right now it's empty, right? Obviously. So if it's empty, we have to hit this line. Well, it's saying we have to set our head to node. So our node is going to be here, which is pointing to null because obviously this is the only element in our linked list. And we're going to make this first node to head. So we're pointing head to node, which we did over here. That's literally it. If we have an empty linked list, we just add it by pointing our head pointer to the node that we created. And we increment our length by 1 and we're done. Now we need to handle the other case when we do have elements in our linked list. So let's say this is our linked list. We have 4 elements in there. So 1, 2, 3, and 4. And obviously we're going to have next properties for all, but let's skip that because I think we know that by now. And first element is going to be the head and 4 is going to point to null. And let's say we have a node with a value of 5 and we want to insert that at the end. That's what push does. So what we will do is we will traverse through our node starting at node 1, which is our head, which is going to be saved into tail. So tail is currently head. Now we're going to traverse through our linked list now. Well, does the head have a next property? So we're going to look at node 1. Well, does this point to another node? Well, it's true, right? So we're going to, this is going to evaluate the true. And now we set tail to tail.next. Well, our tail is head. So what's head.next? Well, our head.next is 2. So right now our tail is going to be the node 2. Before it was the node 1. Now we check again. Well, does node 2 have a next property? Well, it's true. Now our tail is going to be node 3. And we keep doing that. Well, it has a next property. So tail is going to be node 4. And does it have a next property? No. So what we do is we evaluate this line to false and we hit this line. Tail.next is equal to node. So currently our tail is our node 4, which has a next value of null. So we change our next property to node 5. After we do that, we successfully pushed our element into our linked list. So this will be gone and it will be replaced with node 5, which has a next property. Well, we didn't write it actually. Next property of null. So we'll have null over here. We'll write it here. And finally, we increment our length by 1 and we're done. That's it for push. Just remember that if it's empty, we're just going to set the new node to head. If not, we're going to traverse through our node. We're going to traverse as long as our element has a next property. And if it doesn't, we're going to override or replace the next property, which is null, to our new node, which in this case was node 5. Now let's implement our pop method. And before we implement it, let's see how it's going to work. We're going to have node 1, node 2, node 3, and 4. And obviously each one will point to the next one. So node 1 points to node 2, 2 to 3, and 3 to 4. And 4 is pointing to null because it's the last one. And our head will be pointing to this one. Now, pop gets rid of the last node, right? So we want to get rid of this 4. So we want to get rid of 4 and then return that later. But how do we get rid of this node 4? Well, what we do is we traverse through our list and go to the second to last node. So this node over here, node 3. And what we do is we simply set this next pointer to not to point to node 4, but it's going to point to null. That way, we can technically get rid of our node 4 and have a linked list with 1, 2, and 3. And 3 is going to point to null, which means that this is the last one. So this is going to be our tail. Now let's implement our pop method. So pop method is going to remove an element at the end of our linked list. Now we have to do a check. Well, if our linked list is empty, there's nothing to remove, right? So we are going to return out from our method. And next, we want to create two variables. First one is going to be tail, and second one is going to be called previous. Now tail is going to, as the name suggests, store the last node in our linked list, and previous is going to store our second to last element. And remember that eventually our second to last node is going to be the tail after we remove the last one. This is again going to be our tail, and in order to make it fully a tail, we want to set the previous node's next property to null later. Now we have to do a few more checks. Well, if there's just only one element in our linked list, that means that after we remove that element, our linked list is going to be empty, right? So what we do is we have to set head to null to show that our linked list is empty. Otherwise, what we want to do is we want to traverse through our linked list as long as the next node exists. And we have to override our previous node with tail node and tail node with node next in line. And then we want to set previous node. So after step 6, after we traverse through our linked list, you would have gotten our second to last node. So we want to set the next property to null so that we can sever the link between the second to last and the last node. And we want to decrement our length by 1 and return the element that was deleted. Now let's try to implement our method. So first thing I want to do is I want to check if my linked list is empty. And if it is empty, I just want to return. And next, I want to create two variables. Let tail is equal to, I'm going to set this equal to the second node in line. And my previous is going to point to the first one for now. And later, we want to traverse through our linked list. And eventually, tail is going to be the last one. And previous is going to be second to last one. Now we have to do some few more checks. Well, if there's just one element, I want to set my head to null because after we remove it, it's going to be empty. So how do you know if there's just one element in our linked list? Well, if the head's null next property points to null, that means there's just one element. So if this dot head dot next is null, what I want to do is I want to set head to null. So now our linked list is going to be empty. And else, if it's the other case, I want to traverse through my linked list. So as long as the tail has a next property, so in a sense, it's previous dot next, which is same thing as tail dot next. What I want to do is I want to override my previous variable with tail and tail with my tail.next property. Okay, that looks good. And after we're done looping, our tail is going to be the last element and previous is going to be our second to last element. Now what we have to do is we have to change our pointer for our previous node. So previous dot next is going to point to null. So here we're severing our connection to the node to be deleted, which is stored in our tail. And now we want to decrement our length by 1 because we removed an element. And then next, we want to finally return our tail. We have to actually do or previous, and I'll explain this part later. Let's just leave it as tail for now. Okay, let's try if our code works. Now let's console log linked list.pop. We should get our node 3. Okay, so that looks good. And you can see that in our linked list, node 3 is gone. We have length of 2, node 1 and 2 only. Now let's try running it one more time. So we got our node 2. Our linked list has only one node and a length of 1. And let's see what happens when we run pop one more time. We got null, and that's not what we expected, right? We should have gotten node 1. So what did we skip? Well, let's go back up to the code. Now, this is our solution, right? And if you look, we are just simply returning our tail, right? And this is all good, except when we just have only one node in our linked list. So we're going to hit our if statement, and head is set to null. And we are going down here. We're setting the previous.next property to null, but this really doesn't matter, right? Because our linked list is going to be empty, and we decrement our length by 1, and we are returning our tail. And our tail is pointing to this.head.next. Well, if there's only one element in our linked list, we're just going to have our head. So what we have to do is, if tail doesn't exist, we have to return our previous. And this is what I wanted to show you. That's why I skipped it. So let's go back down. And now you can see that our pop is returning the correct node, which is 1. And we have an empty linked list. Now let's try running it one more time. And you can see that it's just running undefined because it's empty. Now let's go over our code one more time. Before we do that, let's bring our nodes. So we have node 1, node 2, and node 3. And let's put one more. And we're going to have 1 point to 2, 2 points to 3, 3 points to 4, and 4 points to null. Now, this first line is checking if it's empty. If it's empty, we're just going to return. So we don't run rest of our code, we just stop. And next, we declare two variables, tail and previous. So remember, this is obviously going to be our head. So in the first iteration, previous is going to be our node 1, and tail is going to be our node 2 because it's head.next is this node 2. Now we check, well, do we have a this.head.next property? So do we have a second node in line? Well, if we don't, we want to set our head to null. So let's try to see that. So let's do that down here. So we have our node, and this is our head. And does this have a next property? Well, does this have a next property? Well, it doesn't, right? Head.next is null. So that means that there's just only one element in our linked list. So we just go all the way down here. We set previous.next to null. Well, if you look, our previous.next is our head. So we're kind of doing redundant operation here. So I guess you can later move that over here, but it doesn't matter. What we do is we decrement our length, and then we finally return our previous variable. And if you remember, when we didn't have this part, it returned null, right? And that's not what we wanted. We want to return the last node that's in our linked list. Now going back, let's handle the other case when we have more than one node in our linked list. So else, we want to iterate as long as tail.next has a property. So currently our tail is 2. So does node2.next exist? Well, it does, right? We do have a node of 3. So what we're doing is we're overriding our previous variable with tail. What's our tail? Well, our tail is node 2. So we override it, and now our previous node is 2. And does tail.next exist? Well, it does, right? We run this whole line because tail.next exists. So our tail is going to be 3 now, and we keep going. Well, does tail.next exist? Well, our tail is currently 3, right? So node 3.next exists. Well, it points to node 4. So it's true. And now our previous is going to be node 3, and for tail it's going to be node 4. So we override it here, and we check again. Well, does node 4.next exist? Well, no, it's not, right? It's null. So we go out of this while loop and hit these final 3 lines. Now we set previous.next, and our previous is what? It's node 3. So node 3.next is going to be null, and we decrement our length, and finally we return our tail, which is going to be our node 4. So we return node 4, and that's how pop works. Now let's try to implement our unshift method, and our unshift method is going to be fairly simple. Now let's say we have our regular linked list with 4 elements. 1 points to 2, 2 points to 3, 3 points to 4, 4 points to null. And currently this is our head. Well, let's say that we want to add a node, and it's going to be 0, node 0. How do we add it? Well, what we do is we have to link 0 node's next property to our head, and after we do that, we set our new head to over here and get rid of this link. And that's literally it for adding a node in the beginning of linked list. So it's going to be really simple. So remember, first, obviously create our node. Second, we want to set next property to current head. And finally, set head to new node. So try to implement it and we will go over our code. Now let's go over our pseudocode just once before we implement it. First thing we want to do is we want to create a new instance of our node. And if our node is empty, we want to set head to node. Otherwise, what we want to do is we want to point new node's next pointer, so next property, to the current head and set head to our new node. And we want to increment length by 1 because we added a new node to our linked list. Now let's try to implement just that. First thing I want to do is I want to create a new node and I'm just going to call it node. And this is going to be a new instance of our node class. And I'm going to pass in my value. Next, I want to check if my node is empty. And if it's empty, I want to set my head to node. So if it's empty, that means that we have no head. I want to set this dot head is going to point to node. Else, what I want to do is I want to have my new node's next pointer to point to the current head. And after that, I want my head to be the current new node. This dot head is going to be my new node. So after that, I just want to increment my length by 1. So that's going to be this dot length. We increment by 1. So that's it for our unshift. So let's try if this actually worked. Let's do linked list dot unshift and let's pass in 0. And something's weird, something's off. So let's go back up and we made a typo here. It should be this, not thi. And I think it should be working now. Let's go back down. And you can see that we have our new linked list. And first one, the head is pointing to node. Next is 1, 2, and 3. And finally, it's null. And we have our correct length, which is 4. So that's it for our unshift method. Now let's implement our shift method. And shift method simply removes the first element in our linked list. So it's opposite of unshift. Now let's say we have our linked list. So 1, 2, 3, and 4. 1 points to 2, 2 to 3, 3 to 4, and 4 is pointing to null. Now we want to remove our head because head is the first element. Well, obviously we want to store this to a variable so that we can return it later. But what are the operations of shift? What we do is, well, first we have to make our second node in line as our head, right? So we have to, currently our head is pointing to node 1, but we want our head to point to node 2. So get rid of this connection. And then after that, 1 is still pointing to node 2, right? So let's sever this connection too. And let's make it point to null. So after we're done with that, our head will be 2. And this would be the first element in our linked list. Now again, first one is set head to second node in linked list. And so second is we want to cut our connection to the second node. So this one, cut previous head's connection. So if you do that, we'll be done with our shift method. So it's fairly simple like our unshift. Now let's implement our shift method, but let's go over the pseudocode just one more time. Well, shift is going to remove the first element in our linked list. And we want to check, well, is our linked list empty? If it is, we want to return because there's nothing to delete. And next, we want to save our first element into a variable because we want to return that later. And next, we have to set the head to the next node in our linked list. Next, we want to unlink previous head's next property. And we want to set that to null so that we can unlink that node from our linked list. And finally, we want to decrement our length by 1. So it's going to be fairly straightforward. First thing we need is we want to check if our linked list is empty. If it is, we just want to return. And next, we want to save that node into a variable. So let's call it shifted. And this is going to be equal to our head because our head is the first element. After that, we want to set this dot head to this dot head dot next. and then we have to unlink the node that we removed. So it's going to be shifted dot next is going to point to null. And finally, we want to return the element that we removed. So let's see if this worked. Let's do console log linked list dot shift. So that gave us the first element and it's pointing to null. So we were able to server the connection. And now we have value 2 and 3, which looks good, but our length is wrong because we didn't decrement our length. But before that, let's just see if it's going to remove everything. Now, if I were to do it one more time, that should return 2. And you can see that we have only one node. And finally, do it one more time, it's null now. And if we were to do it one more, you can see that it's returning undefined because we don't have any node in our linked list. Now let's go back up and handle our length. So we forgot to decrement our length, and this is going to be simple. We just decrement it here by 1, and if we go back down, you can see that we have our correct length. So uncomment still be 0, it should be 1, 2, and should be 3. So it's looking good. Now let's implement our get method, and before we implement it, let's see how this works. So we have 4 nodes like before. 1 is going to point to 2, 2 to 3, 3 to 4, and finally to null. And obviously this is going to be our head. Now let's say that we want to get our node at index 2. So it's over here, right? So this is index 1, index 0, and index 3. So what we want to do is you want to traverse through our linked list, and you want to traverse through it until we hit the element that we want, right? So traverse, and when we reach the element that we want to save that to a variable and just return it as our result. So it's kind of fairly simple, but remember that you are working with indexes here. So we want to somehow traverse through it until we reach our given index. So think about how you are going to do that. That is going to be the probably hardest part of this problem. So think about how you can traverse through it and return the node that we want at a given index. Now let's go over our pseudocode for get just before we implement it. Now we have to check, well, is our linked list empty? If it is, we want to return. And we have to check, is the index out of scope? Well, what that means is index not within our linked list? So if we have 5 elements and then we were given an index of 1000, obviously we don't have an element at the 1000th index, right? So if index doesn't make sense, we want to return. Next, you want to create a variable called current to store the current node, and we're going to initialize it to head. And next, I want to track where my current node is at. So I'm going to create a variable to track the current index where I'm at, and I want to traverse through my linked list until my current index is less than my given index. And I want to set my current node to the next node so that we can eventually get the node that we want. And finally, we want to return that later. So let's implement our code. First thing, as always, well, do we have a empty linked list? If we do, we just want to return. Next, we want to check if our given index is out of scope. So if index is less than 0, or if index is greater than this dot length, that means that the given index is invalid. So we're going to return. And we made a typo here. That should be index idx. Next, I want to create 2 variables. First one is going to be called current, and this is going to store the node to be returned, and I want to initialize it to my head. And next, I want to create a variable named count, and this is going to track how many times we iterate through our linked list, and I want to set that to 0. And now we have to traverse through our linked list. So let's use a while loop, and we are going to iterate through our linked list as long as count is less than the given index. And obviously we want to increment our count variable each time. So let's increment it here. And each time we iterate, we want to override our current variable with the next node in line. So that's going to be current.next. And finally, I want to return my node at given index. So current. Okay, that looks good. And actually, you can just get rid of this here and just to count increment over here. That's totally up to you, but I just want to leave it here. So let's go back down and see if that worked. So let's console log linked list.get, and let's try to get the first element first. So we got our first element, which is node 1, and let's try to get our second element. So that's element at index 1, so we should get 2, and next one is index at 2, so that's our last node. And let's try a index that's out of scope. So let's do 9. That should give us undefined, which looks good. Now let's go over our code line by line to get a better understanding of how get works. So like before, we're going to have our nodes. So 1, 2, 3, and 4. So we have our linked list, 4 nodes, our head is 1, and 4 is the last element. Now first thing we do is check, well, if it's empty, we want to just return. Well, if it's out of scope, so our index is 0 here, 1 here, 2 here, 3 here. If index is greater than our length, we want to return. If it's less than, we want to return also. Now what we do is we store our current head to a variable named current. So right now, current is node 1 and our count is 0. And let's say our given index, or we want to find node at index 2. Now we have our count, which is 0. So let's bring our count here and we hit our while loop. Well, is count less than index? Well, it's true, right? And that's because it's 0 for now and our index is 2. So what we do is we set our current to current.next, which is our node 2. So it's going to be node 2 and our current is now going to be 1 because we increment it by 1 each time. And we do. Well, is our count less than index? Well, it is, right? So let's first increment our count and we get the next node, which is 3. Now we check again. Is count less than our index? Well, is 2 less than 2? Well, it's not. So we exit out of our while loop and return our current. And what's our current? It's node 3. So we return node 3 and we are done. Now let's try to implement our set, but before we do that, let's see how that's going to work. So like before, we're going to have our nodes. Now we have our linked list and set is going to update a element at a given index. So we're going to be given a value and an index and we want to just update that value. And if you think about it, this is exactly same as get. It's just that we're not returning a node. We are just simply overriding our value with the given value. So let's say we want the element at index 2, so same as before, so this one. So we will somehow need to traverse to our linked list from 1 to 2, 2 to 3, and update the value. Value is currently 2, but I want to override it so that this becomes, for example, 3. Let's say that our value was 3. So, well, it's actually 3 right now, so it should be something else. Let's do 3.5. So the value of this node should be 3.5. And after we update it, we are done. We're not returning anything. We're not deleting anything. We just simply want to change the value of our node. Again, this is really same thing as our get method. It's just that we are changing the value instead of getting a node. Now let's implement our set method. So it's going to update a value at a given index. So we're going to have 2 parameters, first one being value and the next one being index. Now again, this is going to be really similar to our get method. So steps 1 through 5 is going to be exactly the same. So first, we want to check if our linked list is empty. If it is, we want to return. If index is out of scope, we also want to return. And we want to create 2 variables. One to store our current node, which we will later store our node at our given index, but initially we're going to set it to head, and next is going to be our variable to track the current index that we are on. After that, we want to traverse through our linked list as long as our current index is less than the given index, and we want to keep overriding our current node with the next node. And after we're done, we want to get the current node's value and replace it with the given value. So now let's try to implement that. So first thing, as always, we check if our linked list is empty. If it's empty, we just want to return. Next is going to be, well, if it's out of scope, if index is less than 0 or index is greater than the length of our linked list, we want to just return here. Now we have to create our variables, and I'm going to call this current to store our node and going to initialize it with head. And next is going to be our current variable set to 0, and this is going to track which index we are on. Now I want to be able to traverse through my linked list. So as long as count is less than my given index, And remember, each time we traverse through it, we want to increment our count by 1. I want to overwrite my current node with the next node in line. And after we're done getting our node, we have to now replace the value. Well, if you remember from our node class, we had two properties. First one being value, second one being the next property. Now what we have to do is we have to change our value property. So that's going to be current dot value is equal to our given value. That's actually it for our solution. And if you notice, everything's the same. So all this code is the same as our get method, except for this one. So let's try if our code worked. So right now we have our linked list with 3 elements, 1, 2, and 3. Let's try to update element at index 1. And we'll do 5. So let's do linked list.set, and we're going to pass in a value, and that's going to be 5 at index 1. And you can see here that the value was updated. The length didn't change, nothing changed. It's just this value changed. So that's it for our set method. Now let's try to implement our insert method. So let's say that we have our linked list with 4 nodes, and you want to push in a node at index 2. So our linked list is going to look like this, where 4 points to null. And we want to, and obviously this one is head, and we want to push in our node 5 at index 2. So that's index 0, 1, and 2. So over here. So how is that going to work? Well, first thing you want to do is we want our new node, node 5, to point to node 3, right? And our node 5 is going to have a next property, and right now it's null. So what we want to do is first get the pointer, next pointer from our node 2, and set that equal to node 3. So now our 5 will be pointing over here, right? And now we have to reset the previous node, so node 2's next property, to point to the new node. So we want to sever this connection and make node 2 point to node 5. So that will be how we insert a node in middle of our linked list. Well, let's say for example that we want to put it at index 0. Well, if that's the case, we actually implemented that method already. So we will just use unshift. What if you want to add it at the end? Well, we can just use push method, right? So we don't have to code the same thing over and over again. So that's actually it for our insert method. Now, before we actually implement our insert method, let's go over it one more time. So this is going to take 2 parameters. One is value and the other one is index. So we want to insert a element at a given index. Now we have to do some checks. Well, if our given index is out of scope, we want to return, because obviously we can't return or insert a element at index 1000 when we have only 5 elements in our linked list. If it's empty, we want to use unshift method. And next, we want to use push method if index is same as length. So that means that we're putting at the end of our linked list. So let's just use push. And next, you want to create a new instance of our node. And now we need to be able to traverse through our linked list. Now, before that, let's create 2 variables. One to point to the previous node and another one to track the current index. And then next, we want to traverse through our linked list until current index is index -1. And we keep updating our node so that we are actually traversing through our linked list. Now we want to insert our new node. So new node is going to point to the next node that was in line, and previous node should point to the new node. So we did illustrate that when we did our illustration. And finally, we want to increment our length by 1. So now let's implement our code. So first thing is I want to check if my index is out of scope. So if it's 0, or if index is greater than the length, which is given by this dot length, I just want to return. Okay, that looks good. And now I need to check if my linked list is empty. So else if it's empty, I want to just use unshift method, and we have to pass in our value. And let's actually add one more case. Well, what if our index is 0? If our index is 0, let's still use unshift, because unshift is literally adding an element at the beginning of our linked list. And now we need the case where we are adding at the end of our linked list. So if index is equal to the length, let's use the push method. So that looks good. Now If it's the other case, we want to create a new node. So const, let's call it node, and create a new instance of our node, pass in our value. That looks good. And we need two more variables, one to store our previous node, and let's call it prev, and this is going to be set to our head for now, and then it's going to be our counter to count or track the current index. Now let's traverse to our node or linked list, and as long as count is less than index -1, and I'll show you why it has to be index -1, and we're going to overwrite our previous node with the next one. Okay, that looks good. And now we need to change our pointers. So first thing you want to do is node.next is going to point to the node that's at our given index. So that's going to be represented by previous.next. And now we need to reset our previous node's next property to our new node. So that's going to be prev.next point to node. And finally, we increment our length by 1. So that's it for our insert. Okay, let's first try to insert it at index 0. So that's insert, and let's insert the value 0. So value and our index. Let's see. So we have 0 as our head. So it did add it to the beginning of the linked list, and our length is 4. So it's looking good. Now let's try to add it at the end. So that's index 2, I think. And we made a mistake somewhere. So it shouldn't be a constant, one of the variables. So let's go up and check. So our node shouldn't be a constant. It's going to keep updating. So it should be let. Okay, let's go down. Okay, let's see if that worked. Now we are inserting at index 0, 1, 2. Well, it should actually be at 3, right? We made a mistake. The last is going to be index 3. And you can see that it worked 1, 2, 3, and 0. So index 0, 1, 2, and 3. So that looks good. And let's try to add it in the middle. Let's do index 1. So let's add it at index 1. And now we have 1, 0, 2, 3. Length is looking good. So now 0 is at index 0. And let's do an index that's out of scope. So let's just do index 5 or 4. And you can see that it didn't add. We have our regular linked list and the element wasn't added to our linked list. So our insert is looking good. And actually, that's it for our insert method. Now let's go over our code line by line because it's a good practice. Now we need to handle our edge cases. The first one is if it's out of scope, you don't want to do anything. We don't want to add an element. Now the other one is if it's empty or the index is 0. So you could have written just index is equal to 0. We want to use unshift method and pass in our value because unshift is technically adding an element at the beginning of the array. And another case is, what if the index is equal to our length? That means that we want to add it to the end of our linked list, right? So let's just use push method. Now, if that's not the case, we want to first create our node, and we want to create two variables. Count is checking the current index. Previous is going to store the previous node. So we had our linked list like this. So we had 3 elements, 1, 2, and 3. And let's say we have node 4 over here. Now we want to keep iterating until our index. And let's say we want to add it over here. So that's index 1, 0, 1, and 2. So index is going to be 2. And we have our node here. So we want to add it over here. So second to last. Well, we're going to keep iterating until count is less than index -1. And if you didn't have index -1, we'll go to up here, and what it will do is node will be added to the end of our linked list, and that's not what we want. So we want to get our previous node, which is 2, and save it to a variable called previous. Now previous is node 2. Now we have to change our pointers. So node.next is currently null, but we're setting it to previous.next. And what's previous.next? Previous.next is pointing to 3, right? So now node 4 points to node 3. So node 3 over here. So after that, we have to reset the previous node's next property to the current node. And we want this node to point to node 4. And we are technically servering this connection. So everything is in line. So it's going to be node 1 to node 4 and 3. And one of the important thing to keep in mind that we can't have this line come before over here, because if you were to do that, our previous.next is pointing to our node here. And if you were to have this line afterwards, node.next is going to be previous.next, which is itself. So that's not going to work. So always have node.next first, and then we overwrite the next property with our current node. Now let's go over how remove works. So let's have our linked list, and let's say that we want to delete a node at index 1, this one over here. So how can we do that? Well, first thing we have to do is we have to handle our pointers, right? So we want to have our node 1, the previous node, to point to node 3 and get rid of this connection. And finally, we want to have our node 2, the node to be removed, to have a next pointer to null. So we are cutting this connection from our linked list totally. And finally, you want to return this node that we removed. And there are a few cases that you have to consider. Well, if it's empty, we just want to return. And what if we are removing at the beginning of our linked list? Well, if we were to do that, we can just simply use shift that we implemented. And what if you are deleting from the end of the linked list? Well, we can just use pop, right? So consider that when you implement your remove method. So this is actually going to look really similar to our insert method. But one key thing to note is that we need to have two variables to store our node. And first one is our previous, just like before. And we have to save our current node or the node to be removed into a variable too. So other than that, it's going to be the same. So give it a go and come back to the solution later. Now, before we implement our remove method, let's just go over our pseudocode one more time. Now, if our linked list is empty, we want to just return because there's nothing to delete. If the index is out of scope, we want to return again. And next, we want to check, well, is the index equal to 0? If it is, we're just simply removing the first element. So we want to use our shift method. And if it happened to be the case that last index in our linked list, let's just use pop. Now is going to be the real stuff. First, I want to create a variable that is going to store the previous node that we are going to delete. And then I want to have a variable to store the element that we are actually going to delete. So this one is going to be the element that we are going to return later. And we're going to set it to head for now. And next, we need a variable to track our current index. And now we want to traverse through our linked list as long as the current index is less than our given index. Now we want to set our previous variable to the current node and current node to the next node. So this way we are traversing through our linked list and overriding our nodes so that finally we can get the previous node and the node to be removed. And now we need to handle our pointers. We want to set our previous node's pointer to the next node. So the node that comes after we delete our node, and finally sever the connection from our current nodes to the next node, and finally decrement length by 1 and return our element. So let's start coding for our solution. First thing is, if it's empty, I just want to return. And next, I want to check if my given index is out of scope. So else index is less than 0 or index is greater than or equal to this dot length. I just want to return. And now I need to check else if the given index is 0, I just want to use shift method. So shift, and if it is the case that my given index is the last index, so this dot length minus 1, I want to use pop. Okay, that looks good. And now we need to handle our cases when it's in middle of the linked list. So let's make two variables, that previous, and let's call this current, or you can call it removed. Let's call it removed. This is going to be set to our head. And next we need our count variable to keep track of our index. And now let's traverse through our linked list. So as long as count is less than our given index, we want to keep overriding our nodes. So previous is going to be our removed node, and removed node is going to be our removed dot next node. And actually, let's call this next node. I think this is a little confusing, removed. Let's call it next. Or you can call it current, or whatever it works for you. And now we need to set our pointers. Now, the first one is going to be, well, we need to set our previous node's next property to the next node, right? And that's represented by next dot next. And sorry guys, I want to call this current. I think it's really confusing. So let's rename it. And then next we want to server our current node's connection. So that's going to be current.next is equal to null. And finally, we want to decrement our length by 1 and return our node. So let's check if that worked. So console log, let's remove our first element, so index 0. So we have our node, we have the pointer pointing to null because we didn't want to point to the node 2. We want to server our connection. And you can see that we have 2 nodes in our linked list and length is looking good. Now let's try removing our last node. So we got our node 3. We have 2 elements in our node and it's node 1 and 2, so that looks good. And let's try to remove node at index 1. So that's node 2, and we have node 1 and 3, and now 2 that was in the middle is gone. And let's remove a node that's out of scope, so 5, and we get undefined, and we still have our regular linked list. Now let's implement our isEmpty method, and this is going to be checked if our linked list is empty or not. So that's going to be really simple, and we want to return a Boolean value. And how do we know if our linked list is empty? And that happens when our head is set to null or when our length is 0. So either of them works, but let's just set it to head. Now let's go down and check if that worked. So let's do console log ll.isEmpty, and right now it's going to return false. And let's get rid of our elements. I'm just going to uncomment these, and you can see that it's returning true because we don't have anything in our linked list. Now let's implement our clear method where we remove everything in our linked list. So we're going to set all our properties to its initial state. So first one is going to be this dot length, and we set that to 0, and we have our head, and that's going to be set to null. So this way we're clearing everything. So let's see if that worked. Let's do ll.clear. So this should get rid of everything that's in our linked list. And you can see that our linked list is back to its original state. Now let's implement our values method where we return the values of all the elements in our linked list. First thing you want to do is create a variable to store our values. And the next, you want to create a variable to keep or store the current node, and this is going to be set to head in the beginning. And now we need to traverse through linked list as long as the node exists and add the value to our array and keep updating our node with the next node in line. And finally, we are going to return our result. So now let's start coding. So first thing I want is my output variable, and this is going to be an empty array. And let's just return that here right now. Okay, that looks good. And now we need to create a variable named current, and this will represent our current node. And we're going to initially set it to the head. Now let's traverse through our node. So while current node exists, I want to push in my values. So output.push, I want to push in just the value. So current.value. Remember that our node has 2 properties. First one was the value property, and next one is the next property. And then next, we want to override our current with the next node in line. So current.next. So let's check if our solution worked. So console log linked list values, and you can see that we have an array with all the values in our linked list. And our linked list consists of 3 nodes, 1, 2, and 3, and we have our values here. Now let's try to refactor our code so that it's more compact and readable. And we are going to do that using the method that we implemented earlier. Now, first thing I want to do is, well, this line is checking if our linked list is empty, right? And we actually implemented a method just for that. We're going to use isEmpty to check if our linked list is empty. And if it is empty, what I want to do is I want to just simply use unshift and passing my value. So if it's empty, this is going to just go straight to our unshift method, which is going to add an element at the beginning of our linked list. Okay, so given that, what I can do next is I want to use get method so that I can just get rid of this while loop. And what do we need to get? We need to get our tail, right? So tail is going to be represented by the last index, which is going to be length -1. So using get, let's do this dot length -1. So that's going to return our tail. And we can actually get rid of our else statement and put this up here. So we create our node, we create our tail, and we set the next property of our tail to our node. And as you can see, this is so much more cleaner, right? And easier to read. So let's go back down and check if that actually worked. And as you can see, we have our 3 nodes, 1, 2, and 3. So it's looking good. Now let's try to refactor our pop method. So same as before, we can use isEmpty to check if our linked list is empty or not. And if we have just one element, let's just use shift. So return shift. So that looks good. And now let's get rid of our while loop. And let's actually get rid of our else statement too. So let's bring this up. So if it's empty, we want to return. If there's just one element, we want to use our shift method that we implemented. And now we need to be able to get our tail. Well, let's do that using our get method. And last element is at length -1. So that's going to get our last element. And previous is going to be obviously this dot length -2. Okay, that looks good. And we set our previous next property to null, decrement our length, and we want to return our tail. So we can just get rid of this. Now that should look good. And let's try our code. So we have 3 elements in our linked list. Let's remove one. We have our last one, which was 3. Let's go down here. We can see that 3 was removed. Let's remove one more. It should be 2. 1 is pointing to nothing. Shift is not defined. Okay, let's go back up. We made a mistake. And I hope you caught that mistake. It should be this dot shift. Okay, it looks like it's working. So let's go back down. And you can see that we got our last node. Our linked list is empty. Let's just do one more time. And it's returning undefined because there's nothing in our linked list. Now let's refactor our insert method. So same as before, I want to use get method to get the previous node. So this should be this dot get, and that's going to be index -1. So we're getting our previous node. We don't need our counter. We don't need our loop. And we have our node pointing to previous not next, and previous not next should be equal to node. Okay, so that looks good. Let's go down and check if our method is working well. And there is one more thing that you can do. You can just get rid of this and change to isEmpty. And you can actually do that for all the methods, but I think I'll skip the methods that only require this to be changed because it's really simple. Going down, let's check if we can insert our element. So insert, you can see that it inserted 0 at index 0. Okay, so that looks good. And how about last index? So that's working well. So index 0, 1, 2, and 3. How about in the middle? So at index 1. So it's working well. Index 0, index 1. We inserted 0 at index 1, and that's what we wanted. And insert is looking good. Now let's do the same thing for our remove. Well, we can change this to isEmpty. Next, we can use our get method to get our current and previous node. So let's do this dot get is going to be index -1. So that gets the previous node, and current one is going to be this dot get at index. And as we refactor our code, it's so much more simple and more readable, right? And that's what we want. That's exactly what we want. And that should be it. So let's go back down and check if it works. Let's try to remove the first element. So that's node 1, and node 1 is successfully removed. Let's do node at index 1, and that was node 2, right? And right now we have 1, 3, which looks good. Length decreased. The last node, which is 3, so that looks good. And how about node at index 3? It should be undefined. Yeah, it's giving us undefined. So our remove is nice and refactored. Now I want to go over our time complexity just one more time, because before we implemented our solutions, I think it might be a little hard to see why it's such and such. But now that we finished, I think we should have a better understanding by now. Now access is going to be O(when) for all other nodes except for head. Head is going to be O(1) because we have a head pointer that points to the first node in our linked list. Otherwise, it's going to be O(when) because we will have to traverse through our linked list. And search is O(when) because again, we have to traverse through our linked list to find the value that we want. Now the most important part. Remember that we talked about how insertion and deletion has 2 operations, and first one being search and second one being the act of inserting and deleting an element. Now, if you remember when we refactored our code, we used what? We used get method, right? And get method simply searches for an element, and that's a O of n operation. But the actual act of inserting and deleting, so changing our pointers, it was at maximum 2 to 3 lines. So for example, we were doing something like previous.next is node, or node.next is equal to, I don't know, current.next, just to give you an arbitrary example. So this operation is really simple, right? And this whole thing is O of 1, whereas searching is the one that takes a lot of time. So that's O of n. So insertion and deletion, it's going to be O of 1 for head, because we have a pointer that points to the beginning of our linked list, which is our head. But otherwise, it's actually going to be O of n when we consider both searching and deletion or insertion times. But I just wanted to point out that it's actually O of n if you consider the whole operation, so searching plus insertion or deletion. But otherwise, it's simply going to be O of 1. If you guys find this helpful, make sure you guys like and subscribe. Thanks.